You're making great progress with building fantastic Java apps and handling errors to ensure they run smoothly. But what if a single piece of code in your app causes more than one exception? Is it possible to handle only one single exception at a time? Can a single try block handle multiple exceptions? In this video, you'll learn how to use multiple catch blocks to handle different types of exceptions and how these can be used to manage specific exceptions. You've just finished programming your latest Java application. You're now ready to check for errors and resolve any emerging exceptions. But despite your attention to detail and great programming skills, there is always a possibility that your code might be prone to more than one exception. For example, consider this code extract. The second line causes an array index out-of-bounds exception. This is because it attempts to access index 5 of an array with only 5 elements, starting at index 0 and ending at 4. It also causes an arithmetic exception because it tries to divide 10 by 0, resulting in infinity. But you don't need to worry about this. Java can handle more than one exception at a time, right? Unfortunately not. Only one exception occurs at a given time, and only one exception handler is invoked to handle it. Well, if that's the case, then why would we need multiple catch blocks or multiple exception handlers? Because the same piece of code could cause different exceptions at different times, depending on the data it works with, just like the one you've recently encountered. In this case, you can use a single try block with multiple catch blocks to handle all the suspected exceptions. Yes, you can write multiple catch blocks for a single try block. If an exception occurs, a catch block matching the respective exception is executed. So, how could you resolve the exceptions you encountered earlier? Let's begin by exploring an example of the syntax for a single try block with multiple catch blocks in Java. Start with the try block as usual and place a code that may cause an exception inside it. Then, include the catch blocks one after the other. Each catch block handles a specific type of exception indicated by its parameter. Here, each catch block should correspond to a different type of exception. Catch blocks should be ordered according to their specificity. A catch block for a more specific exception type should always be placed before the catch block for its generalized equivalent. For example, runtime exception is a generalized exception, and arithmetic exception is a specific type of runtime exception. So, if your code contains arithmetic exception along with other runtime exceptions which you may not be currently aware of, you can deploy multiple catch blocks to handle them. However, you must place the catch block that handles the arithmetic exception before the one that handles the general runtime exception. This is the correct way of handling multiple exceptions in Java. Let's surround the code with a try block. Then define two catch blocks, one to handle arithmetic exception and the other to handle runtime exception. Within the catch blocks, you can place the code to handle these exceptions. The exception object exception gives access to a method named getMessage. So, call the getMessage method on the exception object and print the message. This returns the message associated with the exception as a string. In your code, the arithmetic exception is thrown first with zero division because the assignment operator has right-to-left associativity in Java. This means that the expression is evaluated from right to left. Therefore, the output displays the message divide by 0. Let's try handling the general runtime exception before the specific arithmetic exception. Notice the error at line number 10. Let's find out the cause by hovering over it. It says the arithmetic exception has already been caught and suggests to delete this catch block. Why? Well, because runtime exception is the superclass of arithmetic exception, so we can handle the arithmetic exception also. This is why you must handle the specific exceptions before the general ones. However, If you are aware of all the exceptions that might occur in your code, you can avoid handling the generalized exceptions. For example, you could write a catch block to handle the array index out of bounds exception instead of the runtime exception in the previous code. Additionally, if you feel the need to have a catch block to handle general exceptions too, you can add one at the end, such as handling any runtime exception here. Great work! You've successfully handled multiple exceptions in the same code using multiple catch blocks. Your Java app should now run smoothly with no other issues. When working with multiple catch blocks, remember that each catch block can handle one specific exception type. And if more generic exceptions are required, order your catch blocks from most to least specific.